Good morning. In this lecture series, we see about the general field problem of GDE formulations and the discrete continuous bond. So, the first of all, after the finite element analysis, the general problem of the formulation and discretization continuous model. So, exploring the interaction of the discrete structures and the continuous dynamic and modern computational modeling. So, what do you understand in the challenging on the discretization versus continuous? So, while going for the discretization model, the discretization model is utilize the distinct and a countable value such as integers and a sequence. These model excel the represent the system with the clear and a separable state. So, like integer based on computations, sequence analysis, and the final state system. Under continuous model analysis, the continuous model is represent the smooth and unbroken flow using the revalue functions. They capture the gradual change and the nature, neutral of phenomena is like a real value function, the smooth transition and differential equations. Why both matter in the real world problems is the discrete application, continuous application, hybrid approach. So while going for the discrete applications, the population demography and the counts, digital signal processing, and inventory and the supply chain tracking and network packing route. While continuous applications, the fluid dynamics and the flow of system, heat transfer and diffusion, economic supply demand curve, and whether the pattern is modeling. While going for the hybrid approaching is a many complex systems or demanding the hyper methodologies that is seamlessly combine the discrete decision making with the continuous dynamic behavior of the comprehensive solutions. So the introducing the graphing neural ordinary differential equations. So it can be classified as three. The one is the continuous depth extensions and the vector field modeling and the diverse applications. So GDE is the extensive GNS into the continuous depth and the time domaining moving behind the district layer architecture. The vector field modeling, the model complex and vector field on the graph with a continuous layer that capture the non-linear dynamic neutral. And diverse applications, the particularly useful for the irregularly sample and the complex system in physics and biological and financial modeling. So, while generalizing the disjunctive programming and the systematic frame, the Boolean logic integration, explicit disjunctions, and the structural translations. So GDP is a model to discrete continuous optimizations through the Boolean variable and algebraic constraint the provide the rigorously mathematical foundation. Explicit disjunctions is a represent the logical disjunctions if then else statement exhibit within the optimization problem, making the complex decision logical trackable. And the translation, integrated the discrete choice into the structural mathematical probable and the computation solution methods. So the conclusion towards the powerful and the flexible modeling for the complex system, the foundational understanding, GD that is novel approach and GDP is a framework and is for the mastering the stream the continuous modeling foundations is a paramount of the tackling the model computation challenges. And the graph neural ODE is offer the innovation continuous methodology for the graphical structure and the temporal data. Generalized the destructive programming provide the rigorous structure for the discrete continuous optimizations. And while going for the summarization of this case, the discretization continuous modeling the differential governing of the governing differential equations and discrete the continuous model. So while going for the governing differential equations, the physical law and mathematical functions are the equilibrium constraint, the energy balancing and the conservations. The mathematical functions, the field variable variation, continuous domain. For the applications, the approximate complex and numerical method and the FMEA, we know that finite element analysis, and the efficiency, accuracy, and the practical engineering solutions.